So as people are kind of coming in, I just want to give a big shout out to everyone here. Thanks for coming. I know, I was talking to the Google guys. It's a packed house, so we're really excited to have you here. My name is Dat Ngo. There you go. I'm the Director of Solutions here for Arize, so I work everything in Europe, Middle East, and Asia. I'm technical, I'm a builder, I work really closely with all of our customers. But the first thing I want to do is give a shout out to, before we go over the agenda, to Google. So big shout out to Google for letting us use their studio. So we're really excited for you guys to be here. And what we're going to talk about today is a few things. So let me go over the agenda first. Myself, I'm going to talk a little bit about really just a high-level understanding. So I always like to know, who I'm talking to. I actually just never know what I'm going to talk about until I'm up here. So just by show of hands, who here knows what GenAI is? Just raise your hand. Should be most of you. Okay, solid. Who here has built some prototype on their own personal time? Okay, getting better. Who here has built something for their job, for their business that they work at? Okay, nice. All right, now we're cooking. Who here has run evals? All right, who here doesn't know what the word evals means? All right, okay, now we're cooking. Who here has run their own agent, AI agent, built their own AI agent? Okay, nice. Who here has built their own AI agent platform and orchestration? There should be.
What do you mean by agent?
Like they built their own framework that's being adopted by many, many thousands. Okay, all right. Well, we got Wang in the house, so big shout out. So as we go through the agenda, Wang is our third speaker. Just want to give a big shout out to Chi for speaking here. Celebrity, he's the founder of Autogen. He's at DeepMind, incredible friend to us, incredible speaker, incredible engineer. But I'll be speaking first, and I'll kind of go through the base layer of what are we seeing in the agent space with the companies that we're working with? What is observability? How do you understand if the thing that you built is actually working? So it'll be a super quick 15 to 20 minutes. And then we'll have our CEO, Jason, introduce himself, but he's over there. Thanks, Jason, for paying for all this. He's my CEO. Yeah. Thank you, Jason. He will talk about really agents. What are we actually seeing in this space? What's hype and what's real? One unique thing about our business as Arize is we are the largest observability company in the world, so we do AI observability. So when you deploy AI, you want to understand how is it doing? Is it doing the things you want? And so being able to see across all of the enterprises, across all of the sectors that are doing this, what we wanted to do today was really just share what we see, because it's a really unique perspective, and our job today is really just to educate. And then lastly, is Deepti here? Raise your hand. All right, lastly, can we give a round of applause for Deepti for coming from Weaviate? So good to see you. She runs solutions for Weaviate, and then we'll talk about, has anyone here heard of RAG? Raise your hand. All right, good. It's not 2023, so at least more of the room has heard of this. But so as I get started, I'll go first. Like I said, my name is Dat. My main purpose today is to just educate. What am I seeing in the space and why that matters to you? So we'll talk about three major things. And the things I want to talk about are, one, observability. So when you hear the word observability or AI observability, it really just answers the question of, can I see what's happening in the thing that I built? So when you're building RAG, when you're building agents, this becomes very important when you're root causing the issue, right? We all know that sometimes the systems that we're building now can be non-deterministic. They can start looping. They can start failing for unknown reasons. So how many people here have ever gotten a hallucination or something wrong from ChatGPT? Raise your hand. Okay, should be everyone. All right, that's a dig on OpenAI, but who here has built an AI RAG system or agent system and realized it wasn't perfect, like it was beyond perfect? Okay, good. So this will be super helpful for you as we talk about observability. It's really, can I root cause into the problem and see what's happening? Now, when we talk about evals answers the question of, is the AI product that I actually built performing in the way that I care about. Specifically, every AI product is different, and so how you evaluate it will depend on who you are. And you don't have observability and evals just to have them. It's all with a major goal in mind. And the major goal is really to understand how you can build a better and better AI system, right? The whole goal of this is to build a better AI system that works, and that's really talking about experimentation and improvement. So we'll cover that as well. And so if you guys don't know who we are, one, we paid for your food, but two, we're the largest observability company in the world. So what do I mean by that? So we're this unified platform, whether you're just starting your first lane chain application, or whether you're Booking.com deploying Trip Planner last year. The whole point is that we cover the lifecycle, because the line between development and production in the GenAI space is super thin. What do I mean by that? The same workflows you use in development ends up being very useful in production and vice versa, meaning when you're first starting to learn about evals and you're prototyping, well, those evals that help you get to your first prototype so that you can present are actually the same evals that you want to monitor or alert for in production. So as you're running this thing, you just want to say, hey, are these things failing or not? We'll talk about instrumentation and the rest, but as you're creating golden data sets for development to be able to test, actually the bridge between production and development, being able to create those golden data sets from your production data set, become very valuable. And then we'll talk about the experimentation phase, like when you actually find a problem, how do you experiment on it to understand, hey, how should I fix the system the next go around? And so when we'll talk about the stack today, we'll really highlight Gemini. So shout out to Google for building Gemini. It's a great model. When we talk about RAG, we might cover Weaviate and Google Vertex, so vector DB stores, semantic searches. In terms of orchestration, we'll talk about Autogen, cheese baby. And then we'll talk about evaluation observability, but I don't want to show too much tech and really just keep on the education route. And then in terms of evals, let me actually go to a different slide real quick. I'm going to hop around. But in terms of kind of what we do, we actually have two products today. So what I'm going to show you is a little bit of our open source and a lot of our enterprise. But the whole idea is that we have an open source product you can use right after this. It's completely free. We don't even require a sign up. You can just pip install for those technical people. And we'll have a link to the Git in a second. And so really the first thing I want to talk about is orchestration and instrumentation. So it doesn't matter what framework you use. So I know some people here are using small agents. I know some people in here are using data stacks. Some people might be using LangChain, LangGraph, Llama Index. It doesn't really matter what type of framework you use or if it's completely custom. In order to get the traces, in our product, you can use kind of one line of code to get them. But long story short, this part of adding a little piece of code into your AI application to see traces is called instrumentation. And so the whole idea is it's really easy to do. I'm not going to go into depth here, but this is what a trace looks like. And so really what a trace is, it just tells you what are the pieces of work that an agent is doing. So for example, if I show like a visual representation of an agent, right, like something like this, this is a really dumbed down example of Booking.com's trip planner. So you can imagine, hey, I'm Dat. I want to book a flight to London. Trip Planner will, search for flights, search for hotels. I can say, hey, I like to do touristy stuff. It'll actually build out, a whole itinerary for me. And I can say, hey, I also want the cheapest flight. It'll send me down a different path. But we talk about agent architectures. This is just kind of an example of what that looks like. And being able to visualize that in these traces. So a trace represents a piece of work happening. And now a span is a sub piece of work in that trace. And so Jason will go into depth on really like how to evaluate agents, but I really just want to cover observability and what that means. And so when we look in the product, we can see, hey, I can see what's happening. If I'm doing a RAG, for example, I can see, hey, some user asked a question, right? From that question in the system, we pulled back 2 documents, right? Hopefully these documents can help us answer that question. And then we package that up inside of a prompt template, right, in which we sent a payload into, for example, Gemini, for example. But the whole idea is now we can see what's happening, right? And so, yes, I can look at these traces. I can inspect all the pieces of work that my AI application is doing. But the real question is, are you going to inspect every single one of these traces that happens manually? The answer is hell no. And so what do you do now? Well, the idea is that this is why evals come into play. And so this is a really great way to think about evals. Evals help you discern signal in your application. And so LLM as a judge, folks have used it, great. You know that you can use an LLM to give you signal or feedback, but signal comes in many different forms. It doesn't have to just be an LLM. It could be humans. So you yourself can annotate a data set to kind of label yourself. You might get feedback from the user. And of course, there's other types of evals. We won't go into depth today, but you can also use heuristics. So if you want to validate if something is a valid JSON, you can use code to do that. So it doesn't always have to be a human, doesn't always have to be an LLM. And if you're doing things like RAG, there's some really great ways to visualize metrics. So if you're doing RAG, for instance, this is a good way to visualize it, all the different metrics. In our platform, for example, you can run evals yourself, and we're agnostic. But what we're starting to see is this persona, two personas. So you have the AI engineer who's technical, right? That's probably most of you guys. But then you're also forced to work with the AI PM or the SME, if you will. And you're starting to see this separation of work. And so in our world, yes, you can code and do LLM as a judge. But in our world, you can also just run this in a UI. And this is very helpful for those folks who don't code. They just want to say, hey, I want to run an eval. And I want to run an LLM as a judge on some window of data. Great. And we have a bunch of out-of-the-box evals. But the cool part is that if I'm not technical, I can just create my whatever Arize eval, blah 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 blah. And this is great. But in our worlds at Arize, we always want to think a little bit further. And for us, PMF, for product market fit, has always been, how do I help our users become lazier? So when you start thinking about like AI product design, so if I'm super lazy, what if I just say, hey, Arize Copilot builds an eval on toxicity. So and I can even misspell toxicity and it's fine. But the whole idea is that we'll see this throughout, but our central thesis is that AI one day will observe and troubleshoot other AI systems. We don't think that it's very scalable for every single human who's built 30 applications to be able to eval this over time. And so I can just simply ask our Copilot, like say, hey, just build this eval, and it's just built the eval for me. Just like you're a human, you have access to those traces and all the data on those traces. So does it. And it knows like, hey, the output should be toxic, non-toxic. I can change this. But the whole idea is that now I can click save and run. And then now when I come back into the traces, I have these evals on it, right? So now I have these traces that'll say, hey, this thing did well or not well. Hey, this hallucinated. And it'll actually tell me why. It'll say, hey, this RAG process hallucinated because the answer introduces information that's not present in the RAG, right? Basically, the LLM came up with something outside of the context that I gave it. And so this is super helpful in determining, hey, these things are going well or not well. And now, you can do things like, hey, show me where every single piece of work that happened has hallucinated. And of course, you as a human can say, hey, filter on this stuff. Show me where I hallucinated everywhere. Great. But then when we started to think about these workflows that AI engineers really wanted, it just goes past filtering. Copilot can actually just say, hey, find where input traces talk about some issue, right? In your world, it might be a specific domain or some topic. This is about SDK data, so I'm just going to say the word copying. But long story short, Copilot can actually do the searching for you. We realize that folks don't just want to search on criteria or metadata. They actually want to find semantic topics. So the whole idea is that Copilot can actually go ahead and find examples of, hey, where are things that we're talking about like X, Y, or Z? And it's a semantic search. But all of this is to say, I need to find issues, whether they're evals or this topic or some other topic. And what do you do with observability and evals next, right? So I can see what's happening, I can see what's broken. Well, the natural next step is to try to fix those things. And so in our world, we take those things that we found. So if I had 15 examples of X, Y, or Z, you can start to curate these data sets. And this becomes important later for those learning to fine tune or those learning to want to create golden data sets. You can actually go in and create these data sets. And what it leaves you with is examples of anything. Good things, bad things, this type of eval, this subject. And then you can start to iterate on these things. And so the whole idea is that, hey, here's this data set that represents this thing. Now the next question is, what are the things that I need to do to go and fix that thing? So if this data set represents, for example, hallucinations, things that went wrong, I need to go and fix these problems now. So how are AI engineers kind of doing this? In our world, we call this experimentation, but imagine you have to iterate on prompts, or imagine you have to iterate on a new model, right? The whole idea is you want to see how are these things run and how did they perform. So you can take that data set, keep it steady, and if you're super technical, you can run this in like a CI/CD way. If you want to say, hey, here's some data set that I have, I want to do these 5 tests on them, and then I want to see how they perform. But again, in our world, we have people who don't code, and they need to be able to do this stuff, right? And so the idea is that we can actually, since we have instrumented, new word, all the processes that are happening, and we can see them, I can say, hey, in this piece of work, I see 1 or 2 or 3 LLM calls. I can go to the LLM call or whatever checkpoint I want to come from, and then just take it into prompt playground. I can basically replay it. So here what I see is here's my prompt template with some variables. Here's those variables. And here's the output the first time I ran it. So this is super long and verbose, and I kind of hate it. And so the whole idea is I can come in here and say, hey, make this less verbose, for instance. And the whole idea is that now I can choose, we have the original model that is chosen here. I'll keep that, but I can change it to whatever model. And I can rerun the new prompt, right? And so now I can see that the new prompt is way shorter. That's great. It's much more concise. My users are going to like that. But we don't just get to kick off from one data point. We can actually load in those entire data sets, right? So I can actually load in that data set that represented whatever. In this case, it's hallucinations. And so maybe I want to do something like fix these hallucinations across the entire data set. So what am I going to do? Well, I'm going to be super lazy. I could fix this myself, but I'm going to use Copilot and just say, hey, hallucinate less, for instance. And so you're starting to get this theme. PMF is really help you be lazy. Copilot's going to read the old prompt and say, hey, this is what the old prompt was. It'll actually give reasoning tokens for what it's about to change, right? So it says, hey, I'm trying to address your concern of hallucinating less, and I'm going to make the following improvements. And so it'll actually go in and produce the new prompt, and it'll add that kind of final step. And it'll say, hey, it added steps 3 and 4. It basically says, hey, if you don't know something, just say I don't know, and reason through it. And I can accept it, and now my prompt has changed, and I'll just rerun this again. So now the difference is instead of like lying to me every single time, it just says I don't know now. And so the whole idea is that I can save that experiment run off, and it exists here. And then I can do things like say, okay, I ran a bunch of experiments. I can inspect a specific experiment. Actually, I want to inspect 3 experiments that I ran across 2 evals that I care about, right? And the reality is you'll get something like this, right? You'll start to see that, and it's not always binary where this prompt engineering fix is the way. If you ran 5 evals, for example, you might notice that this one experiment performed really well, but it did really well in 3 areas and kind of mediocre in 2. But the whole idea is this is the iteration cycle that AI engineers are going through, right? So when we work with our biggest customers, Uber, Spotify, Booking, many, many other very large enterprises, this is the workflow that they kind of need. And so just super high level, I'm not going to go through the rest, but when we think about why observability is important, it allows you to root cause. When we talk about why evals is important, it allows you to discern signal in that data. And then the last step is once you've discerned signal, how do you go in and fix it, right? And then this is the iteration loop. The faster you get through this loop, the faster your AI product will actually perform and be, you can think market ready for you startup people or enterprise ready for that VP that you're presenting to. So hopefully that makes sense. That was a really high level version of kind of what we do. But just wanted to quickly show a little bit of Phoenix. If you want to scan that, Phoenix does all this and it's free to use. And so it's one of the only platforms that's based off of open telemetry. That is a small detail, but if you're working in the enterprise, that small detail is very important as you mature up. Most of our enterprises understand the value of that, but Phoenix is completely free to use. It gives you observability. We integrate with all the major frameworks, but that was a high-level introduction to observability, evals, experimentation. I hope you got a lot out of it from an education perspective. And yeah, we'll definitely, if you want to grab me after the talk, we can always talk shop. But really appreciate you all. And then I'm going to present the next speaker. So Jason will cover very deeply and in depth agent evals. I think agents is a completely kind of new world. So please give a big shout out to Jason.
Thanks. How's everyone doing? Awesome, awesome. So you've heard about Arize. And Arize. So first off, we've recently announced we raised 70 million, 130 million already raised. Probably the leader. We are the leader in the observability evaluation vertical. So thank you all for coming here. We need to spend that money on something. The one thing I really like to do, like if you come to San Francisco, you come to the Bay Area, you're going to feel like this energy of AI. There's probably like 30 events a night covering every single subject you can imagine. And a little bit of what we're trying to do is bring that energy out of San Francisco to other spots. Try to do this stuff in technical detail, and then feel free to also answer questions too. So a little bit of what we're trying to do is take the AI energy and bring it outside. Someone asked me earlier today what I think is going to be big this year, and I see it every account right now, which is assistants and agents. Everyone is building these, and then you hear, well, what is an agent and what is an assistant? And it's just this theoretical thing. In the end, what I view it as, I view it as a first generation of AI was this prompt and response, this simple input output, maybe traditional ML-ish type thing. And what I see people doing now is using tool calling, which is like a cognitive branching, is kind of my view, is people use it to determine what path to go in your system. You're iterating over data, you're iterating over things, you're doing long-running tasks. So there's a potential now to have AI go accomplish an amazing amount of new things. And then we get to sit over an incredible customer base. And so I see a lot of what people are building, and it's amazing. So what you're going to see coming out of this space, expect magical products. Many built on Gemini. Thank you, Google. But an incredible amount coming here. So what I'm going to talk to you tonight about is making agents and assistants work is hard. It's hard to make this stuff actually do what you want it to do. It's not an easy button. The Twitter demos look great. It's hard to ship that Twitter demo because there's so many use cases it's hitting that don't work. So we've worked with clients a lot to do this. So first off, as I hinted, it's kind of the year of agents. On one side, you have frameworks, which are Autogen's here, Cheese here from Autogen to talk about that framework. But there's things you're using to build agents. There's tooling, which is kind of enables all of this, which is model support. Tool calling is now ubiquitous. Quick question for you: how many of you know what tool calling is or function calling? Okay, that's a decently big group. How many of you don't? Or is anyone okay to raise their hand and say they don't know what tool calling is? All right, there's a handful of you. I'll try to. I think I have some examples here where I can talk a little bit about it. But long story short, a ton of frameworks. You don't have to use a framework to build an agent. Many people don't. But there's a lot of tools that you get from these frameworks to help you build agents and assistants. We support both. We'll trace and track these frameworks. We help you understand what's going on underneath. We also work if you don't. What do these look like underneath? This is just two examples. One's llama indexes. This is a linked graph example where there's like almost like nodes and graphs. And some of the agent frameworks are high-level, abstract, prompts that represent the agent. Some of these actually have almost like state machine views. So there's a lot of different abstractions and approaches out there. We have to support all of them as the independent player in this space. But just know as you're building, there's an incredible swath of tools. And the stuff, the hint I'm going to give you here is making this stuff work is hard. All this stuff aside, what do we see in the simplest case is something like this, which is There's a router, which is an LLM doing tool calling. It just is determining what tool to call based upon some input. And the tool just tells, like, it's kind of like a branching decision. Any of you are engineers, it's like what do I go do based upon what is someone's asking. And then in that branch, you might go do something. And this is an example from our Copilot, which that was demoing a little bit, which is our own assistant that we built. And the tool calling might have subsequent LLM calls. There might be one LLM call that determines what you do next. There might be a lot of LLM calls in a branch. You might have deep trees. You could have multiple levels of this. Or you might just iterate back to the same, the same level. So big picture is there's control flow with LLMs. There's LLMs that do maybe skills or things below that control flow. And there's iteration on data. This is kind of like the heart of most agents and assistants that we see out there. There's also state too. I feel like state might just make things complicated. There's a lot of assistants and agents without the state pass between each level here. But you'll also hear about memory and state as people are talking about these agents. So it's about control flow using LLMs. It's about these branches. It's about state. How do you evaluate these? Well, you're going to hear evals used out there, evaluations, and I'm not talking typically about benchmarks. There's some, the ARC prize, and how many of you guys know about the ARC, the ARC, ARC2 just got announced, I think today or yesterday. So there's benchmarks out there to see like how good are models and agents and assistants. They're general tests. They're like I feel like a little bit like SAT tests. What we really mean is like these task level evals. So they're really your business tasks that you want this thing to do. Is it doing what I want it to do? Can I break that task into multiple steps and make sure it's doing what I want it to do for each one of those steps? So we don't mean benchmarks when we say evaluations, which you'll hear out there. It's evals is a very broad term. What we mean is like doing evals on specific tasks that you want this thing to do. What's the challenge? Well, in one of these frameworks, this is an example of like building an agent or assistant in one of these frameworks. That's 20 lines of code. On the right here, you're going to see 100 different calls. So you're building an agent and assistant. If you're using one of these frameworks, there's a lot going on underneath the hood. There's a lot that this thing is doing that's really hard to figure out and troubleshoot and debug and improve. So first off, the hard thing to do is like, how do you make this work? First, you need visibility into it, which is where the tracing comes from. But you also need to evaluate it, which is where some of the element as a judge comes in. And we'll go through an example of like what's a real agent example here. I have a simple example here where there's a router call where you can imagine it's getting a question from a user. And is that question about searching for a product, or is that question a general question about a product? So typically there's an LLM with a tool call that's determining where you go and what you do. Inside that branch, you're going to do something specific. Tool calls give you the control flow. You might do some LLM work inside a branch to do something specific. It's the core building blocks of agents and assistants. LLM routing, and then branching and doing something inside that branch. Give an example. This is just our rough example of like what we think we see in the ecosystem. Things can get much more complicated. Examples here, LLM calls are in yellow. You might have multiple LLM calls in a branch that feed each other. You have one router that's determining what to go do. This is just an example of what like a system might look like. Example, I think we built this, something like this internally, just the demo stuff. What do I mean by evals on the different kind of building blocks? Well, you might have evals on understanding whether the product search was correct. You might have some eval to make sure it called the right skill in the first place. So these are kind of typically engineering. You break down a problem, and you break down it you break down your test into different problems here. And evals here can be like very low level engineering and checking if your search is working. But we also see evals as product level things like Did this, is the person frustrated in the conversation? It could be product level outcomes. So we're seeing multiple levels, like product managers writing them, we're seeing engineers write them. It's just using AI to see if your system's working correctly. Working and performing well are not the same thing. You've seen Twitter demos that work, but then you go put them in a real situation, the thing just doesn't do what you want it to do. So this is an example, and I think I think Dat said to this one well, which is like we see LM as a judge and code-based evals and annotations as probably the core checks of most systems here. Have a question for you is, how many of you have heard of LM as a judge? Yeah, I mean it's a good set. Phoenix has had LM as a judge and as an open source product probably for a year and 8 months or something. Like it's had this idea in there for a long time, which is essentially you have an application and it's doing something in AI, but you use an evaluator LLM on top of it to see if it's working correctly. So you're using AI to see if this thing is doing what you want it to do. And there's an eval template that's a prompt that feeds that works with the evaluator LLM and basically checks whether this thing is working correctly. So you're using AI. It's kind of a meta idea, using AI to make sure AI is working correctly. I promise you, I've seen hundreds of customers scaling right now, and this is the most used important thing. People doing immense amounts of evals on their platforms. This is kind of how you make AI work. It doesn't supplement human annotations. Humans still need to be in there, make sure it's working. It just, humans don't, they don't scale. So Elm as a judge, this is pretty, this if you haven't used it or you don't know it, these are going to be everywhere. It's in the product lines we have. An example now is you're using LM as a judge, you're using AI. Well, what are the right questions to ask? Well, for the router, you might ask, did I call the right skill? Did it do the right thing? Was I looking for search, but I really just answered a question in the wrong way? And then part of the routers is parameter extraction. It's in the details here. But did I get that right? Did I extract the right things in the right way? That fails a lot. To be honest, a lot of times you call the right skill, but the extracted parameters actually are kind of buggy. And what do you do to fix it? Well, you add to your router template. There's a prompt that decides how things are. There's function definition in a router template typically. So router level evals, am I kind of doing things the right way? You might do product level evals, conversation level evals. Is the user frustrated? That one happens. We do that one a lot. And yes, users get frustrated a lot in these systems when they're not built well. And so there's overall kind of evals that are conversation level evals as an example. There's also an idea of if you're doing steps, am I converging? Is it just running in the background? So you might want an eval to understand, are you actually getting to an answer? Maybe there's some critique on each step. So these are kind of another example of ways of using AI to observe and understand if it's working correctly. And then this is another plug for Phoenix. I'm going to try to. I'm also going to give a little bit of a demo. So this is this right here is Copilot. It's basically traces from our Copilot. So we use our own product to debug and build our own product. Welcome to AI. But what we do is so each one of these are traces of basically calls. So in this case, I might be doing some search, some embedding. I might be doing a tool call here, which is that kind of router thing I was telling you about. There might be some search function I do, and there's evals here at different levels to understand whether this thing is working correctly. There's different types of evals. We have evals that are trying to detect jailbreaks. So someone trying to hack this system, tell me your system prompt. So it kind of got the jailbreak right. So you have people just dropping stuff in. You can use AI on top of your data and your AI system to detect and understand what it's doing. And these are run as jobs, as as Dat was showing, on top of your data. So these are jobs you set up, like that LM as a judge that we're showing you there. I can use Vertex, Gemini on top of it. And this is a prompt that runs on top of your data. And basically augments the system with the eval. So you can build out router evals filtered on certain types of decisions. You can build out frustration evals, user frustration. So all these are AI trying to augment and understand the traces within your system, which are really the segments of information of what's being done. So to build these systems and build them with quality, you just can't do it without building evals and tracing observability. These systems are core to making this stuff work and work well. I think with that, I'm going to pause. Any questions? Yeah, I'll take questions for a sec. Any questions on building? Go ahead.
I'm just wondering, you mentioned some agent frameworks there. So people building frameworks, like custom frameworks without using those static frameworks.
Yep.
And some of the use cases are like frameworks as a planner and executors. So
Yep.
agent system, some agents makes them plan, gets job done with executor. Mm-hmm. And in those scenarios, where does this evaluation you do right now fits into that scenario?
Yeah. I think so it's a good question, and I think you're asking if you're not using one of those frameworks, how does stuff? So first off, I still think tracing and instrumenting is key. So we support, we instrument if you just want to manually instrument with OTel. So it's a standard way in which you'd instrument. I think what you want to do is break up your system into the little pieces of work that are testable. So you probably would have a planner span. You'd probably have an execution span or whatever it's doing. And I think what you're typically doing with evals is trying to figure out what do I want to test, and how do I get the data into a context window to make sure I can make this evaluation decision. So maybe the planner needs all the information that went into the plan. Maybe it needs the results of the plan, the output. Maybe you even take the results of the final results of what came out at the end. But you need to kind of first off, what data do I need and what do I need to put in the context window? Those end up being prompt variables, which are attributes you add to the tracing instrumentation. And then the evals will leverage that data that you've kind of added to your instrumentation. So the planning one, I do a planning eval and evaluation to understand if the plan is correct. I probably would do an eval at the execution layer to see if it's either converging or if it's got that outcome correct. And then sometimes we have very different, for example, in Copilot, we have AI search here. But then we also have one, we have examples here. I don't know if this is a good example. We have whole dashboard creation of widget stuff. So there's different tasks you might go do that are very, very different from imagine an agent comes up with a plan, but one of those things it might go do is search the internet. But another thing it might go do is write a research report. And if they're very different tasks, you might do evals separately for those tasks. Our evals for dashboard widgets are totally different than our evals for AI search. So that's, hopefully that gives you kind of a little bit of an answer on it. Cool. Anyone else? Don't be shy.
Hi, Jason. So my question is, what would you say are the primary benefits of using Arize or Phoenix over going the route of building your own custom evals and sort of experiment tracking using existing tools like MLflow or weights and biases?
Yeah, so good question. My view is kind of the evals themselves are kind of these independent objects, and the evals are like a template you build. So I don't think there's Arize evals or other evals. It's like a template that you own and you're going to bring from system to system. I think if you compare ourselves with weights and biases, I think that they started in the training space. They're trying to come over to this space. I think there's just quite a lot from a product perspective that's, I would say, a gap. So you're going to see from a tracing perspective, tracing on 20 plus frameworks. You're going to see online evals. You're going to see code-based online evals. You're going to see multiple comparison, playground runs that you can play off versus your playground, like when you find a problem. From a product perspective, I think there's a lot of gaps for using the stuff in production. And so you've got some products. So that's a good point. You've got some products that like have gone the development flow, which is like you have a CSV, you drop it in, you play it in a playground, you compare runs. There's folks that have gone the tracing route. And I think they're really my real competitors, and I think weights and biases, I know Lucas, I love the team, but the competitors in the space are actually a smaller set right now. And all my competitors and myself have kind of merged these products into one. Development and production are one thing. And really strong, you'll see a product line here, incredibly strong in production, but an incredible set of development flows as well. So hopefully it answers the question. There's a suite of things you're going to want from production, and tracing, online evals, Cody-based evals, AI search, dashboards, monitors, all those things that you want in production in addition to your development flows, which are CSV, drop a CSV, play in a playground. And you want that all on one platform, so unified platform. Go ahead.
Hi, Jason. So may I respectfully disagree about the product market fit? Instead of making the user lazier, I think it should be more specific about what the value that this is driving. So I can struggle to see. Well, imagine if I'm a senior executive who doesn't understand much about AI observability, how would you describe the value and convince them to procure a product?
Yeah. So the value and the reason to procure our product is if AI is important to your organization, which I would argue a lot of people that it is important. If you want this thing to work and work well, and work well enough that when you would put it out there in front of customers, and you're confident the thing's going to work, and you're going to know when it's not, and you're going to know how to fix it and improve it, and you're going to make the stuff make this investment in your organization that's supposed to make you better than your competitors. Like, you cannot make any of this work without picking me or my competitor. Like, you will have to. If you're deploying AI and you don't want it to make up loyalty programs like Air Canada, or you sticking this externally facing someone. How do you know it's what it's saying, what it's making up? In that loyalty program, they then had to go legally enforce it. How do you know it's not saying something like that? How do you know your products and users are enjoying your product and working with your product? And how do you know it's answering the questions correctly? And if you don't do this, your competitors are going to eat your lunch. So I would just say that to make AI work and work well, you need to pick me or one of my competitors. I'd like to fight on those terms, but you cannot really make this stuff work without picking one of us. Yep.
Hi. Thank you, Jason. My name's Julian Darley. And my question is, since you've just mentioned it and you have done before, one of the key questions for all AIs, and it has been virtually from the start of the revolution, if you like, in November 2022, is how do you do, if it's not a trade secret, how do you do that checking of confabulations and hallucinations and so forth? Where's your ground truth? How do you know that?
Yeah, so it's a good question. Like, how do you do the hallucination check? I don't think there's any... I would argue for hallucinations, there's not like a secret magical sauce. Typically, what we see is for the hallucinations that customers care about. Now, this isn't OpenAI hallucinations in general or Gemini hallucinations, but this is like corporation. Most corporations are using these assistants and agents answering questions on data. There's data right there that they're answering that question on. I'm responding and answering on a docs or something. we see all the time is basically stuff added or changed, or adding some extra information outside of what's there, and that extra information can be checked relative to the grounded data. So what we do is we don't we can't answer what's the birthday of Michael Jordan, and we can't tell if it's making up something random global fact wrong, but we can tell if it's answering a question and adding in information that wasn't grounded in that answer, which is, to be honest, the biggest problem when you're talking about these assistants and agents on local data. But we don't have a solve for the general user using OpenAI or Gemini chat interfaces. That's a challenging problem. Go ahead.
So, Partha Gopalakrishnan, I'm not a technical guy.
Yeah.
So, in this new world, everybody's going to use agents. Let's assume I develop an agent, I use it, and you have an agent, right? So, how do I do evaluation on your agent, right? So, because what I understand is I can get as intrusive as I want on my side.
Yep.
How does it work?
Yeah. So the question's really around if there's a third party developing something, what do you do in that case? I still think the evals, as long as you can grab inputs and outputs of these systems, you can actually get automated kind of checks from AI. So AI can kind of watch the system, watch the inputs and outputs. It's a little hard to figure out what exactly is broken inside it, but I would definitely still use evals even if it's a third party. It really is quite useful to understand if the thing's doing what you wanted to. But again, you might have to kick it back to the third party to actually fix the problem. Go ahead.
Is there anything being done in the testing phase in terms of prompt attacks? Because that's also an important aspect when you want to build an application and you want to cover a lot of, basically cover the whole domain that you're testing on.
Yeah, so I think you're talking about attacks first, so I think there's a whole suite. I feel like there's a set of companies that are in the red teaming area that are kind of going at this space, and we're kind of I'm watching that from a distance here, with people building examples, but it tends to be a service type thing I see out there, like these businesses. Some people trying to add automating tooling to do red teaming automatically, but yeah, I still feel like that's a little in its infancy, and we're kind of seeing how it goes. We partner with some of those teams. Some of those teams kind of use our software, but it's still right now kind of a side business relative to what we do. I still think it's important for teams to test, and it's one of the types of tests that you should build out in the beginning.
Last question.
Yeah, last question.
Sorry. I have a good last question.
Yeah.
Hi, hello. Thank you for the product.
Yeah.
Congratulations with your second round or next round, actually. What is your vision for the future plans, especially for the open inference? Maybe integration for the MCP or ACP?
Yeah.
And the good question, and should we expect Google Arize deal?
Can't answer the last one. But that's funny. So great questions, actually. So super in the details. So open inference is basically a way in which we have map OTel and use OTel to instrument applications and leverage OTel to do GenAI, essentially. The OTel working group, which I'm a part of, the team's a part of, is kind of working to fully standardize some of this stuff. So our goal is to eventually just get the ecosystem to one approach, and we will adopt as that those decisions get made. I still feel like that group is still, I don't know if it's months. It's going to take a couple more months, I think, for the decisions to be made to feel stable enough to then like converge everyone. Long story short, there's a standard for instrumentation out there called OTel. There's not a standard on top of OTel that's perfect yet, that's there yet for all of our systems to talk to each other. We will get there. Open Inference is one of ours we support to help make this easy. The second one was MCP. MCP's been all over Twitter and all over there, and it's generally the idea of some of this tool calling, kind of extending it across systems a bit. That's kind of my view. Extending MCP, a standard way in which you might do two calls to another server, running something and coming back. It's super exciting in terms of like the potential. You're kind of standardizing some of the flow here. And so for us, we think a lot about how to trace that, track that, troubleshoot it, how to, where we play as a role in it, both as maybe offering servers or at least troubleshooting the servers that you put out there. So one deep one to watch. How many people know MCP in this room? Okay, yeah. I guess Twitter and Blue Sky are doing their job. So yeah, very, very interesting to watch. A very fast-moving space. MCP, all of our people building. There's whole businesses being built with MCP services right now. And then the last question on Google. Yeah, I don't have a good one for you. With that, I'm going to let Chi from Autogen. Super excited for Chi. Autogen, I think, is one of the first, and I talked about high-level and low-level frameworks, but it has both. Chi's amazing. He's probably one of the I don't know, the OGs or godfathers of the agent framework space. So excited to invite him up. Yeah, do you have a mic?
Hi everyone. Have you heard of Autogen? Could you raise your hand? Okay, great. Yeah, that's good. Very good. No, I will talk about AG2 and observation with Autogen later. But before I talk about Autogen or AG2, I want to first talk about the idea of like building an agent OS so that they can help the developers to build and optimize these agentic AI systems. And then I will talk about AI AG2 like key concepts and also learning from the community. So yeah, thanks to Jason who had a good setup for like the concept of agents, agentic AI systems, and so on. About 2 years earlier, I made this big bet early big bet that agentic AI is going to be the future of the AI systems, and it can maximize the power of these generative AI techniques and do really useful things for us. There are several dimensions around it. Number one, it has a very natural interface, and number two, it has a strong capability that can help us execute very complex tasks. But there's also one more dimension if we think ahead a little bit. That is, if we have these agents built everywhere that can do all sorts of things, even if they begin to be very simple, but if we connect them together, we can achieve much more. So this multi-agent interaction is another dimension we should think about and use that. Think about that as a new kind of software architecture to build software in future in very different ways. But it's although there's a lot of promises, it's not easy to achieve that goal. So there's a lot of challenges and a lot of decisions to make to build really optimized agent AI systems. In general, we want to optimize for different metrics. Initially, success rate, and once you achieve the really high quality success, you want to also reduce the cost, reduce the latency, and etc. And also reduce the manual effort of doing that. And in terms of optimization choices, it's a huge new space because we're dealing with a very new type of applications. We have choices to make, like what models to use, what prompt to use, what tools to add to the models, how do we connect to human inputs, and also orchestrate all of these, both at the low level, like tools, models, and also at the higher level, like between multiple agents. There's a reason to think about how to solve the problem. But let me first show you like some successful example and see what we learned from the community who are using AG2 to build their applications. And since I'm in London, I want to use a local example. This is an example from Boris Boyle. I want to make sure that the name is correct. He's from the University of Cambridge. Actually, he's sitting right there. He's done some amazing work with cosmology using AG2 to build AI agents that can reduce the human analyst's job, like a full day, reduce their full day of work and reproduce that with just tens of seconds. And the results are quite nice, and they also have an open source open source solution on GitHub. Let's take a look of like how it works. So this is the CMB agent built by Boris' team. It has a natural kind of chat interface. The user, like a cosmologist, can ask a question to the system, and there are multiple agents starting to work to solve that question. So initially we see that there's one agent using GPT-4o to think about the plans. It will send that to a formatter agent and nicely record and format that plan into some nice form. So here's the plan about what are the steps needed to finish the task. But that plan may have some flaws, may not necessarily be the right plan. So there will be another reviewer agent potentially using a different model to criticize that and make recommendations. Again, these recommendations are made and formatted in nice form so that other agents can consume in a nice way. And after a few kind of such situations, the several agents reach a consensus that, okay, we now have a good plan, we can execute. And during execution, there will be more agents involved. Some agents are like researchers, playing the role of understanding the domain and making other suggestions. And other agents will be like engineers who write code and execute code, etc., etc. So there are also agents that are very capable of using some domain-specific software, like cosmology-specific software, so that they can do really hard and deep tasks. So yeah, hope that give you a feeling about how that system works. And there's a lot of lessons and a lot of like trial and error eventually to reach this high quality of result. Here are some examples. The number one is the planning and control strategy is super critical, and also there's some very important ways to make that planning stable, and instead of just generate some plan and execute some different plans. So we need to make sure the agents follow the plan very faithfully, and that's not easy. So there's a lot of tricks used, and what's interesting is that this kind of technique does not only work in cosmology. They have tried it in some other very different tasks like finance or in stock research and many different domains, and it seems to be working also very well. So this is also one common lesson learned from different users from the community. So hierarchical planning seems to be an effective way. And there are tons of lessons similar to this, including how to use tools, how to kind of generate dynamic system message as we carry on the tasks, and we sometimes need to update the instructions based on the states and so on. So yeah, these are some very useful lessons, and the result is very remarkable. So I've heard a story that some students given a task and can't solve the task in 3 days, and the agents are able to solve that in 15 minutes. And also there are even like fundamentally new science results discovered that's at a PhD level. And not just in cosmology. I've learned a lot of these similar stories from other domains, like in protein design, material design, and etc. So yeah, I hope that gives you an intuitive idea, like what is useful. Because here we need to do tons of experimentation to really find out the optimal choices, and how to do the experimentation to quickly so that we can keep our system modular and making changes in a modular way, so that, and also simplify our thinking process. That's super important. Because there are just so many different choices we make, and making them more structured and have a good decomposition of the task can help a lot. But the agent OS not only want to simplify the process, but also want to enable the advanced users to explore all these advanced patterns, sometimes even new agentic design patterns that no one has ever tried, and those are often also important for each particular domain. So we wanted more people like Boris to achieve this. And in the same time, we want to minimize engineering complexity and reuse as much as possible. So that's the idea. That's the reason why we want to build this Agent OS as a common infrastructure to help developers. And AG2 solve these problems with particular design. It has, for example, has an intuitive unified agentic abstraction. That's a very flexible multi-agent orchestration, and also provides composable agent design patterns using these fundamental concepts. So here's just one slide to summarize the most essential concepts. It's quite easy to understand. So we want developers to think about absolutely complex applications in simply 2 steps. The first one is to define the agents of different roles, and the second step is to get them to talk. As simple as that. So here the agent abstraction unifies several different types of entities, language models, non-language model tools, and human inputs. You can easily create an agent with these primitive backends or mixture of them. But how do you create like a stronger agentic AI systems? Just like what you saw earlier in the cosmology example, you can first create these simple agents and then find good ways to make them work together so that they can solve bigger problems. And we provide multiple kind of primitive building blocks corresponding to different conversation patterns, including more fixed flows like sequential chats, as well as more flexible patterns like group chat, and flexibly make them work together. And also some specific types of group chats like swarms, which are really useful for agent to hand off tasks to others, and also shared context. That's kind of inspired by the OpenAI Swarm framework. But in general, there are a lot of there are several like important fundamental building blocks you can use, and you can easily construct a stronger single agent using this multi-agent, for example, by nesting multiple agent chats inside the agent, so that single agent can talk to other agents and present as a stronger ones, but internally they can use multiple agents behind. Similar to the routing idea that Jason presented. Here are some examples of the new features enabled in AG2 just using that simple concepts. We have been developing a lot of rich agent design patterns, and here are some examples of the recent ones. In terms of the interface, we provide some new capable agent that simplifies the multi-agent system. For example, the real-time agent is able to talk to users in real voice, and but working together with some other agents as a backend, which doesn't use voice. And cabinet agent, I will show that in a second, is a very powerful way of automating the design of multi-agent systems. Still, we need to have very strong base agents for that cabinet to work very well. So we're providing some commonly used agents like document processing, navigating the webs, even doing deep research, and they also can build on top of each other. For example, the deep research agent heavily relies on the web server agent. And reasoning agent is also a very powerful way to make any model, not just the thinking model, to be able to perform long-term reasoning and planning just using the agentic approach. So we're still making the improvement to the fundamental agentic-oriented programming architecture to make it really easy to program them and also interoperate easily with other libraries and tools. So here's just a simple explanation of how the cabinet agent works roughly. It has some similarity to the routing idea Jason mentioned, but generalize that. It's similar with the router idea. When users use the cabinet agent, they only need to deal with a single agent. They give the very hard task to the cabinet agent. They don't need to worry about designing other agents and creating a multi-agent system. The cabinet agent will do that for you, for them. Cabinet agent will analyze the task, decompose the task into smaller steps, and then decide to either use the existing library of agents or create new agents if they're not good enough, and create a team of agents. And after this team of agents finish the task, it will have the evaluation part. It will make some judgment and reflection and think about what is not good enough. Then in the next step, they will create a new team of agents. So the evaluation could be very important here as one of the steps to keep this Kevin agent improve. And over time, it will also create new tools and new agents and add to the library so that Kevin agent can improve itself over time when you use it more. So that's the rough idea. It's still experimental, but it shows us a good promise about what we can achieve. Here's one example of a GUI built by our community called Wadis. When users use this GUI, they don't need to write code. They can just drag and drop some unit blocks and create a multi-agent systems easily. And this particular example, we just use the Kevin agent. So the design of the system is very simple. But underneath the Kevin agents, when trying to answer a question about the YouTube video, the Kevin agent decides to use different agents. Some are good at finding the video, finding transcripts, and analyze transcripts, and so on. So there are different agents working together for answering that question. I think the question is what TOC says after the question, isn't that hot? Let's see how well this team of agents is doing. We see these multiple steps like extracting captions and so on. Okay, eventually, I think it found the answer. Okay, so that's it's a good way to kind of actually to get started. If you don't know, like you have no idea how you should design your own multi-agent system, you can give it a try to ask the Kevin agent to try. And even if it doesn't always solve the problem, it has to give you a starting point because you can look at what the Kevin agent is trying to do and figure out what is good to keep and what is still need to be improved, and you can do them by yourselves. Okay, in the last part, I want to just to quickly mention that one way to optimize system is to do a lot of experiments by yourself. But another way, as we seen today, is you can learn from what others are doing and learn. I personally learn a lot from the community, from those diverse applications, from their top achievements, from very challenging benchmarks, and also this domain experts using our domain knowledge to build really cool stuff. So now I want to spend a little time to explain the community. So I started this AutoML project about 6 years ago, open source, called Flammo. And about 2 years ago, we started building this Autogen inside Flammo. And we, in October 2023, we moved out to a standalone GitHub repo. And then since then, the community size just exploded. Now we have more than 20,000 members on Discord. And over the time, we also make a lot of changes and developments. And so now the founders and the most of the community are working on a fork called AG2. So AG2 is the founders' vision of Autogen. And we are still continuing to see a lot of increase in the downloads and use adoption of AG2. And most of the features I talked about earlier was after this fork, and we make really fast development. So I really appreciate the community's efforts. It's a collective effort that makes this project thriving. And most excited about the diverse use cases from both big companies and the small startups. Here's a very small sample of the example of the production use cases. You can see they span across many different domains, including agent platforms, including chip design from NVIDIA, and customer support, even investment research, software engineering, and testing, and so on. A lot of these efforts are actually way ahead of the curve before most people started doing that. For example, the deep research feature, maybe you have heard this year, that is the community has been doing that at least 1 year ago. So this Beneficiary Lab, for example, used that to generate a full investment research, full investment report based on the simple business idea with very high quality. And that's also have hundreds of times of cost reduction. Yeah, so these are so there are so many interesting learnings we got, and some of the lessons I already talked about, like hierarchical planning, and usually the domain expertise plays a big important role to properly decompose the task. So once you have the right decomposition, you don't actually need that many agents, and just a small number of agents can work really well. But how do you find out those lessons? There are two ways. One is to check our repo called Build with AG2. This is a new repo we're starting to curate to collect some of the example use cases. It's still fairly new and far from complete, but I hope the community will work together to make it more complete. And another way is to join our community talks. We host regular talks from researchers, developers, and entrepreneurs that talk about multiple different topics, such as different use cases in different domains, ecosystem collaboration, and also the frontier research in the agent AI space. So that's also a good source for learning. For example, there's one talk we hosted from Global AI who built some top-ranked software engineering agents that can fix bugs on this very challenging benchmark called Sweet Benchlight, almost half of the time and with very, very cheap cost. And that's a very small team achieving amazing result. In general, we have seen this is a trend, like these new techniques enabling small teams or individuals to achieve much more than they could before. So that's all I'm going to say. And here's some links to our GitHub repo and the Discord community. You're welcome to join other agent builders and share your learnings together. And together we can build more and more optimized agent AI systems. You can also find me on these different platforms, and I'm very happy to engage, to follow up with you if you have any questions. Thank you so much. I don't know if I have time for questions. Your call.
Take a couple questions.
Yeah.
I got one here.
What would you say is the main advantage of using multi-agent systems versus one agent with multiple tools?
Mm-hmm. Yeah, that's a big question I often got asked. In fact, if you can use one agent with multiple tools, I'd rather use that approach instead of using multiple agents. That's when I started designing Autogen. That's the first approach I tried. I tried to put as much instructions as I can into one LLM-based agent, and then just have another agent just simply execute the code. The other agent doesn't need any large language model. So you can either say that's a single agent or two-agent system. Doesn't matter, but it's the simplest agentic AI system that we can potentially design. And I found out that for simple tasks this can work, but as the task goes more complex and the number of iterations goes larger, the single LLM often forgets the instructions and can't do everything as I wanted. This forces me to kind of break down the systems and break down the tasks, and then it works much better. Even when I use a cheaper model, I sometimes can outperform the single agent system with a stronger model. Another way to think about it is, even though you can potentially make, let's say, if the model becomes stronger, you can potentially replace your old system with a new model. But there's a lot of concerns about, for example, if you already have certain functionalities tested with existing approach, with existing prompting, prompts, tools, and so on. Now, if you want to extend that functionality, if you just simply modify the existing system, either prompts or tools and so on, probably you can make it such that the new functionality can be supported. But what about the existing functionality? They may get regressed, because when you're making a change that's not monotonic, often you make a change at one place for maybe add one tool. Ideally, the old tools and the old functionality shouldn't break, right? But in reality, that's not always guaranteed. So even when you do simple things like adding some tools, you get big regression, and that's a big headache. But if you use multi-agent design, you can make sure that if you don't change the existing part of the existing agents, then for the existing functionality, they will continue to work well and they will pass the unit test. And for the new functionality, you can do a separate unit test. This is also some lessons I learned from some of the users. They found the multi-agent system is much easier to kind of do unit testing. Yeah, these are some just examples of arguments for multi-agent. There are many others, but these are some practical reasons I want to mention. Yeah.
Last question.
No.
Hi, would you mind just briefly touch upon some strategies to stabilize kind of the planning procedures?
Oh, the planning.
Yeah.
Yeah. So yeah, this is also some lesson I just learned today, but by talking to Boris, you can talk to him more about it. But the idea here is that we should not only use the natural language about like enforcing the plans, but also we should use some structured data structure, right? For example, we can have a JSON structure about the different fields, and then later when you instruct the other agents to follow the plans, provide these structured fields into their, inject them into their listen prompts, and also when they finish the task, you should update that instructions on the fly. So by combining these several tricks, you can make the process much more stable and make them not to forget the previous plans that already be made. So have some separate structure information. Yeah. Thank you very much.
All right, next up we have Deepti from Weaviate.
Sorry, everyone. My name's Deepti, and I'm really nervous right now after those presentations. I hope you appreciate my cute diagrams, because that's what you're getting right now. Hi, the display, yeah, this one. So I have presenter notes as well. Uh-huh. Okay. Is that because I have a lot of... Oh, yeah, what? Oh, okay. Oh, great. Thank you. Yep, so hi. Intros, my name's Deepti. I have been a programmer for a few years now, making games and apps in multiple languages. I work as a partner SC at Weaviate. And before I dive in, let me just say thank you to Arize for having me here in the company of some amazing presenters. a lot of what I shall talk about has probably already been covered by Jason and Chi. Thank you for doing the legwork. At this point, I might as well call my presentation Why Use Evals. So Weaviate is an open source AI native vector database founded in 2019. They've cultivated a very vibrant open source community. We constantly have roadshows, hackathons, enablement sessions, and we are continuously getting feedback from teams and developers about how to make, what kind of tools and utilities they would need to ensure a seamless integration with AI in new applications, in existing applications. So myself, in my role as partner SE, I've been fortunate to talk to these people. And as Jason mentioned, it's the year of the agents. It's amazing how multiple teams are now they're discussing about where AI can fit into their plans for the future. And what I would like to view this as, or this presentation as, is take a more architecture or an orchestration view on the kind of workflows that we are seeing people talk about, what kind of issues you might experience as you build up these workflows. For the architects in the audience, a lot of this might seem repetitive because if you've been working with distributed applications, a lot of the validations, the restrictions that you put in place for flawless executions of distributed systems, similar structures might need to be put in place for agentic workflows. Let me start with a simple function calling agent. I know Jason kind of touched upon this earlier. An agent or a function calling agent basically requires a language model and a list of services that it can choose from. So depending on your implementation, depending on which platform or framework you're using, you might be able to use libraries that convert these functions into tools. These functions could just be simple functions. They could be external services. But you might either be, you can use a library to convert this, like I mentioned, into tools, and then pass them to the agent. Now, once this agent is executed and a user inputs a query, the model then decides which of these tools will need to be invoked. It then responds with the name of that tool and the parameters that you would need to invoke that tool. So in this case, a user putting in an input of, so you see there are 3 services, check weather, book flights, check calendar. For an input, when's the next bank holiday, the model then replies with the tool called check calendar and the parameters that need to be called. Now, depending again on the implementation, you might have agents that execute these functions for you, or you might have to do it yourself. Now, as queries get more complex and users are allowed to input more natural language-based queries, you might expect these agents to start talking back and forth. Now, I know Chi just mentioned about how it might be better to use steps instead of, and one agent executing multiple tools, or steps as some frameworks would let you. So it depends on your implementation if you would rather have one agent performing all the functions or multiple agents, each having its own responsibility. One thing you could do potentially is every agent could, all the agents could possibly communicate with the same model, or every agent could have its own, communicate its own model. For example, you might have a financial reporting agent that uses a generative model suitable to create reports. You might also have an agent that converts user input into SQL commands, and so it's, specific to its own responsibility. Now, again, Jason also mentioned state. Agents that linearly process linearly or not, process queries will have to share state. So either you could have agents sending in events, or you could have them sending, updating a shared state or memory where whatever is the current state of agent 1 is then updated in the state. When agent 2 starts its execution, it uses that agent 1's current state as its own initial state and proceeds. Again, depending on the implementation and which framework you're using, it might be called context, it might be called state, or you might use events to pass that data. Right, so this is, these are the kind of queries, rather, that we would hope we come to a point of executing, right? Like natural language. These are the queries I would like my travel booking agent to resolve. I know Dat and Jason showed us a workflow of what a travel booking agent might have to do. This is such a simplified version, but this is just to kind of show the back and forth between responsibilities of an agentic workflow. So what are the kind of issues we might end up seeing? For example, a lot of the issues you will see are just amplifications of the issues you currently see in models. Now, we've got lost in the middle, which is basically models tend to focus on information that is sent in the beginning or an end of a very large prompt. And if you have a workflow with a number of agents and a very large context where each agent has its own set of instructions that keeps getting added to a context, there is a possibility that some instructions that were provided very early on in that workflow are lost. So an example is an agent that fails to consider past instructions and takes incorrect action when receiving a new query. Another one, similar but not, is unlocked context windows. Similar thing, when you have a context being shared by multiple agents, and if some of those agents are actually responsible for authorization, you might have an authorized context window and then a man-in-the-middle attack where a malicious attacker can take over that context and do stuff that are not right for the system. This could also mean someone asking for personal information. You could have a customer service agent that has already authorized a user, and a malicious attacker could then ask for sensitive information. Again, contextual awareness, related to contextual awareness. Now, if you have agents that depend on external states to make decisions, it's absolutely important to safeguard these agents against a volatile external state. So for, again, coming back to financial agents or trading bots, if you have an agent that helps you execute, listens to market information from multiple sources and then helps you execute transactions, any volatility in the market could have your agent executing transactions it should not be doing. In these cases, if you have something like an emergency stop or a circuit breaker, that could be a fail-safe against this kind of this particular use case. But again, we'll talk about that a bit later. Hallucination amplification. Again, we touched on this before through previous talks. So this is especially relevant for RAG agents, RAG retrieval augmented generation, where agents retrieve data from multiple sources, could be vector databases, could be your SQL, NoSQL databases where you're retrieving diagnosis or past information about patients and helping the model provide a response that is more appropriate. Now, it could happen where partial information provided by these agents could be misinterpreted by a model and then converted to harmful information. Hallucination amplification is something that we are already aware of working on. Something, again, was touched upon earlier. Safeguarding against this is especially important for regulated industries like medical, legal, financial. Undesired input. This might seem familiar for a lot of the developers, if there are in this audience. This is, again, we might have agents that take user input and directly convert it into commands that can be run on their system. Now, that could be a database, that could be your filing system, it could be anything that's internal. Without any sanitization of input, these systems are exposed to injection attacks. This is a very common injection attack that you might be knowing of. Likewise, files could be deleted, personal sensitive information could be retrieved, data leakage. Function call failure. This could potentially happen if there are too many tools to call from, if any of the tools have not been described correctly. As I mentioned before, the multiple frameworks have their own ways of defining the tools. You might be asked to create a function map, in which case it's important to also provide a description of what that particular function does. If those are not properly explained, a model may not be able to find the right tool when executed. So in this case, instead of choosing check calendar, it actually checks, asks us to invoke check weather, for example. And lastly, operational issues. This could be anything from too many API calls, throttling, could be security breaches where a model is meant to download information from some external API, it accidentally downloads malicious data, crashing, or just infinite looping where it's trying to access external APIs and just goes into an infinite loop. Now, obviously, that's not an exhaustive list, and any workflow in an application might have more than one issues. But these are some that I guess we could start off with, and to get to a place where we could potentially have successful executions of our our application requirements. Now. There are multiple ways that we could put fail-safes for some of the issues I've discussed. And as mentioned, there might be more than a couple in a few, and there might be more than one fail-safes needed in an application. Let's start with one. Hard constraints. Now, this might be the most easy to implement. This is basically just if there are any variables that could potentially, certain variables that going beyond might put your application in an inconsistent state, use those values. Define these constraints, define explicit permissions on which actions can be executed, which not. So for example, put a limit on trades and volumes, API limits to avoid throttling, whitelist domains if your agents are going to be accessing external API, timeouts. So basically, just to ensure correctness and consistency. Pre and post LLM validation. A lot of talk about this already. We have lots of APIs already. Bedrock has guardrails APIs to make sure that users' input and output responses are validated. We could potentially also have things like what commands are acceptable or not. These are, again, the kind of evals, I guess, that that Jason and that touched on as well. Redaction of sensitive information in input and output. So a lot of pre and post LLM validation is something that's already been done right now. We could also have assertions. There are libraries that allow you to add assertions in your code. If those assertions are not met, it just stops the execution of those agents. So a lot of operational issues can be fixed with hard constraints. Now, behavior shaping. If your applications have certain goals that you can define, it's possible to use rewards to correct any drift in the responses by the model. Now, for example, hallucination is a really good case. In this case, is a really good example. It's essential that when you start adding a rewards service, it's essential to actually decompose your goals into smaller sub-goals. Consider a customer service agent that you basically start rewarding or giving points whenever it completes a user request within a set amount of time. If you start rewarding these agents for, say, a number of requests in a particular hour, it might start escalating, customer requests to humans quite quickly. It might resolve the cases without actually resolving them. So it's important to actually break it down into make sure that you ask good questions. If the agent ends up asking good questions, that could be a rewarding behavior. Penalize it when the agent has not been performing correctly. Now, to do this, you might have a framework that's called the supervisor worker agent is really helpful, because you then have an agent looking over other agents and then using guidelines to ensure that those agents are actually performing well. This reward service might be a custom service that you built in your own application, or you could use external services. You do have a few libraries right now that end up evaluating whether a model has been hallucinating, say, for example. Another useful use for the supervisor pattern is corrective action, where you ensure that every action has a redo action. This is especially useful when when your application might enter a state that's that needs to be reverted. For example, a transaction that is not right for the system needs to be rolled back. Again, you might be able to do this with the supervisor worker framework, or you might also have multi-agent cross-validation, where any particular task is actually performed by a couple of agents, and and you're able to check whether the other agents perform the same way. Again, this is a great way to tackle hallucination. When the same query or the same responsibility is given to a couple of agents, and one of them behaves differently, you know that there's something weird going on. So lack of reasoning, contextual awareness, these are the kind of cases where you might be able to use behavior shaping. Structural. Now, it might be better to use routers in cases where you don't want model making decisions on direction. There might be certain states in your application where, if your application reaches that state, stop. This, for example, I mentioned the example of a trading bot that executes a lot of transactions if the market goes crazy. This might be a good example there as well. External systems, you could have external systems running in parallel to run checks, or you could do this with routers. Human in the loop, this is especially useful in the medical sector, where there might be certain actions that are prohibited, in which case the agent stops execution and transfers it to a human. Multi-layer access control. Useful if you have a workflow that accesses sensitive information. Only those agents that actually need access that information will have to go through multiple layers of security before they can. This is useful if you are nervous about security breaches. A lot of emergency stop kind of situations are what come under structural. You might also consider quarantine or sandboxing a particular agent if it reaches, and this is something that might be more useful in your development phase when you're testing out your agents, you're testing out your workflows. The moment it goes to a state that's not acceptable, you put it into a quarantine mode. Dynamic self-correction. Now, this is something where if you have agents that are able to self-score, that are able to understand or provide a confidence score on their resolutions. This might be something, again, we have the supervisor worker agent design pattern over here, where a customer, where an agent kind of realizes that it might not be very certain of the answer, and then it then passes on the execution to another agent or a supervisor agent to then continue that flow. This, again, for a customer service chatbot, is a good example where it acknowledges its certainty and asks for clarification. You might be able to also add a human-in-the-loop kind of design pattern along with this. Hallucination also could be resolved over here for models, again, which hallucinate and are able to score themselves. We might be able to resolve that use case here as well. So a very quick recap. When you know certain values can cause harm or inconsistent state, it's easier to use hard constraints to encourage exploration while making sure that no harm is done. For models and workflows where you want to ensure that they are not drifting from the goals too much, and if they are consistently being irregular in their responses, you might be able to use reward shaping to guide their behavior towards more intermediate regular states. Structural are like stop signs and circuit breakers. You stop the system if something's going wrong. You make sure that there is no runaway behavior. And dynamic self-correction. When confidence is low, it prevents reckless behavior, but at the same time, it allows the agents to continue running. That's the end of my presentation. Guys, do you have...